Good morning, everyone. Myself Anburaj, Assistant Professor from Department of Electronics and Communication Engineering, SRM Mother College for Engineering Technology. Today we are going to see about instrument transformer and its types, current transformer and potential transformer. In general, transformer is an electrical device which is used to perform the process of step up or step down the available voltage depends on our application. So here we can see that primary coil as well as secondary coil. So if you are applying a 220 voltage in the primary side, we may receive around 110 or 120 voltage as a secondary coil. How it is possible? Because of the number of turns present in the primary as well as secondary coils. Here we can see the primary coil has a many number of turns compared than the secondary coil. Okay, then we are applying a 220 volt. It exhibits more number of flux compared than the secondary coil, and also it observes less number of voltage from the primary side. So this is what we are having a 100 around 100 volt of voltage of voltage as an output. Okay, so this is a process of step down the voltage from the maximum voltage to minimum voltage. Now we are going to see about instrument transformers. So instrument transformers are special type electrical devices that are used to measure high voltage as well as high level currents in any electrical circuits. These measured high level voltage and measured high level current can be transformed to the manageable level of current and voltage, which can be easily measured by our standard measuring instruments. So we can see that a small and cheapest instrument transformers available in our transmission line measurement. There we can see a current transformer as well as a voltage transformers. These current and voltage transformers measures the high level voltage and current. This can be transformed to the manageable level of current and voltage, which can be easily measured by our standard measuring instruments. Then purpose and function. So first one is measurement. The instrument transformer is also provides accurate measurement of high level voltage and high level current in any circuit. Next one is production. The instrument transformer is also act as a protective relay. It ensures safety and also it finds some faults in our distributive lines. Once if you find the fault reduction, then we can improve the quality of the service. Okay, and then the isolation, which also offers isolation between the high voltage power circuits and the low voltage measuring instruments, because it acts as a bridge between this high voltage power circuits to the low voltage measuring instruments. Types of instrument transformers. So there is a two type of instrument transformers. One is a current transformer, another one is a potential transformers. So the name itself, we can say that the current transformer is going to be measure high currents. So these high currents can be convertible to the lower value of the currents, but the lower value of the current is always proportional to the primary current, right? So in case of a potential transformer, which is used to measure high voltages, okay, so these high voltages can be scaled down to the manageable voltage levels. These manageable voltage levels are always proportional to the primary voltage level. Okay, so this is a main type of current transformers and potential transformers. Now we are using in all our heavy power consumption as well as power delivery circuits. If we are going to constructing any instrument transformers, we have to follow certain ratios. Am I right? So first one is transformation ratio. This is a ratio of primary winding current to the secondary winding current in case of current transformer. Okay, in case of voltage transformer, I mean potential transformer, it is the ratio of primary winding voltage to the secondary winding voltage. That's all, right? So nominal ratio, it is the ratio of rated primary current of primary winding to the rated current of secondary winding in case of current transformer, right? If it is a voltage transformer, it is a rated primary voltage to rated secondary voltage. That's all. So this is the ratio for nominal. Okay, so next one is turns ratio. For current transformer, it is defined as ratio of number of turns in the secondary winding to the number of turns in the primary winding. In case of potential transformer, ratio of number of turns present in the primary winding to the secondary winding. We can see a small difference. For a current transformer, it is the ratio of secondary winding to the primary winding. In case of potential transformer, it is the ratio of primary winding to the secondary winding. So this is a formula as well as rules for the turns ratio for our construction of instrument transformers like current as well as potential transformers. Next one is a ratio correction factor. So this is nothing but ratio of transformation ratio as well as nominal ratio, which one we have already seen in the previous slides. As we discussed in the previous slides, we have two types of transformers. One is a current transformer, another one is a potential transformers. And now we are going to see about the current transformer. So current transformer is a step-up transformer. Therefore, it steps up the primary voltage and step downs the primary current. Hence, in the current perspective view, the current transformer is step-down transformer. Right, so we can see the diagram itself. There is a two coils. One is a primary side coil, another one is a secondary side coil. If it is a primary side coil, it has a few number of turns, okay, whereas the secondary side coil has a many number of turns. Okay, the primary side coil has connected with the line current, where the secondary coil has connected to the our measuring systems like ammeter, or measuring instruments like ammeter. Right, so how it is possible? Okay, we can see a relationship between the winding currents to the number of turns. Now we can see the primary current of winding is directly proportional to number of turns present in the secondary winding. Okay, so the primary winding current is directly proportional to turns present in the secondary winding. Right, so this is the ratio relationship of this current transformer. Okay. The normal range measuring instruments like ammeter, wattmeter, energy meter are going to connected in our secondary windings, because of our current transformer, the secondary winding is going to exhibit a manageable level of currents which can be easily measured by our normal range ammeters, right? But whereas the primary winding is going to connected with our line current. So the line current connecting primary winding exhibits a lower level of current to the secondary winding. Hence it is measured by our in normal ammeters. Okay, so the secondary current ratings are starting from 0.1 ohms to 5 ohms, which is a manageable one. Okay, but in case of primary current ratings, okay, in the primary coil current ratings are varies from 100 ohms to 3000 ohms, which means these current transformers can use to measure 100 ohms of current to the equivalent manageable current. This equivalent manageable current is always proportional to the primary current present in the line current. Okay. Next, we are going to see about type of current transformers. So there is a two type of transformers. One is a wound type, another one is a bar type, which is depends on the primary and secondary winding present in the current transformer. The first type is wound type current transformer. So in this type, the primary winding has several turns. Okay, there is a very less turns. Then only we can satisfy the current to the number of turns ratio. Okay, already we have discussed it in the previous slides. So, but this primary side winding were fixed inside the core of the transformer, whereas the secondary winding is placed in the outside layer of the core. Okay, so this is a practical transformer. This is a real-time transformer which is available in the market. The range of this current transformer is 0.1 ohms to 100 ohms. So moreover, 1 ohms to 100 ohms of current we can measure by use of this current transformer. The second one is a bar type current transformer. So we can see that from the diagram itself, it has only one winding, that is known as a secondary winding. Okay, this line is act as a primary winding in this bar type transformer. Okay, so this line is going to connected with our line current, right? This line, this rod, this line will be act as a primary winding. It transfers the current, lower level of current to the secondary winding. Then the secondary winding is going to connect with our ammeter for the corresponding current measurement. Okay, so this measured current is always proportional to the primary current present in the line, right? So this is a real-time practical bar type current transformer which is available in the market. Another type of instrument transformer is potential transformer. The potential transformer is going to transform the higher value of voltage to the lower value of voltage. This lower value of voltage, then it can be easily measured by use of our ordinary voltmeter. Okay, so the lower voltage is always corresponds to the higher voltages which is present in our primary coil, right? So the transformer is performs the operation of step down operation. So if we are discussing about the turns ratio and the voltage ratio, turns and the voltage ratio, we can see that the voltage available in the secondary winding is always directly proportional to number of turns present in the secondary voltage, right? So depends on this coil ratio, the potential transformer performs the step down operation to measure the higher value of voltage, to convert the higher value of voltage to the lower value of voltage, which can be easily measured by the our now we can see the circuit diagram of this potential transformer. The primary winding has more number of turns compared than the secondary winding, which means it exhibits more number of voltage, but the secondary winding, it observes the very less number of induced voltage. Then it can be connected to the voltmeter, which means it performs the step down operation. The step down the voltage can be measured by the voltmeter. Okay, so as we said, the measured lower voltage of this instrument transformer, I mean this potential transformer, is always proportional to the high voltage present in the line, because the primary coil is going to connected with the line. Okay, for a safety purpose, the secondary coil is always connected to the ground to avoid some unavoidable circumstance. And we can say that the primary winding of potential transformer is rated for 400 volt to several thousand volts, whereas the secondary winding of potential transformer always rated for 400 volts, which means the 400 volt of secondary voltage can be easily measured by our usual measuring devices. Right, the potential transformer is also used for measuring a high level voltages, and also it acts as a protecting device for feeders, generators, and it also helps for synchronizing the feeders and generators. The instrument transformer has many applications and many advantages. That we see several advantages of these instrument transformers. First of all, it provides very less power than any other measuring instruments, and also it acts as a protecting device like relays in any circuits, and also it provides safety to the operator as well as the equipments present in the circuit. Okay, irrespective of the magnitude of the electrical quantity, it helps to fixing the rating of low range meters, and also it is useful to measure various electrical quantities to our specific applications. In substations as well as transmission lines, it provides supports for monitoring the voltage and current level in real time. In energy metering, it provides some solutions for building in high voltage installations. In productive systems, it provides inputs to circuit breakers and productive relays to isolate the faults. So the instrument amplifier is essential for us because it converts the higher value of voltage and current to the manageable level of voltage and current, which can be useful for all of our applications, right? So with these few words, I conclude the topic instrument amplifier. Thank you.